In example 1, we have the quadratic equation x squared plus x minus 2 is 0. And we've solved things like this already this semester where, well, this one you can factor pretty easily where, let's see, we get x plus 2 and x minus 1 is 0. And because it's set equal to 0, you can plug in -2 and 1 for x, and both of these are solutions to the original equation. Now, there's another method that you can use to solve this if you're having trouble factoring it. Any equation of the form ax squared plus bx plus c equals 0 is a quadratic equation, and if it's written exactly in this form, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, these are solutions to your equation. So if we go back to this original problem, the fact that we have x squared plus x minus 2 equals 0 means we do have something written exactly in this form, and a, b, and c just represent the coefficients in front of your x squared, x, and constant terms. So a is equal to 1, b is equal to 1, and c is equal to -2. You can take these values, put them into this equation, and it tells you the solutions. So let's actually try that out. So x is equal to, okay, -b is going to be -1, plus or minus, this is to indicate that we're going to have two solutions to our equation, which we already know we should. I have the square root of 1 squared minus 4 times, let's see, 1 times -2. And this is all divided by 2 times 1. So just directly plugging in a, b, and c. And this is the answer, but let's simplify it to see if it compares to our -2 and 1. So I have -1 plus or minus the square root of 1, and we have minus and a minus, so it's a positive, and an 8 all over 2. X is equal to -1 plus or minus, that's the square root of 9 divided by 2. And the square root of 9 is 3, so my solutions should be -1 plus or minus 3 all divided by 2. That's two things. That's -1 plus 3 divided by 2. It's also -1 minus 3 divided by 2. And this is 2 over 2, which is 1. That's great. And this is -4 over 2, which is -2. So the two values we got using this equation match up with what we have for factoring. So that kind of like checks to verify that this is actually true, but you can use this formula anytime that you're dealing with a quadratic that you don't know how to factor. So we probably didn't need it for this one, but perhaps it'll be useful for more complicated equations. Okay, so for example 2, I'm just going to directly go to the quadratic formula to solve this equation, but you have to know what a, b, and c are equal to, and as it stands, it's not written in the appropriate form. You have to have 0 on one side of your equation. So I have 2x squared plus 15x, and I'm just going to subtract 8 from both sides. Now perhaps we could factor this one, but I'm not even going to bother. I'm going to write down that a is 2, b is 15, and c is -8. I'm going to directly plug these things into the quadratic formula. That's -b plus or minus the square root of, okay, it's 15 squared minus 4 times 2 times -8, all divided by 2 times 2. So this should give you my answers, and it looks like there's going to be 2 of them, so let's just simplify it. We have -15 plus or minus, I'm going to get my calculator out for this, just to simplify what's under the square root. 15 squared minus 4 times 2 times -8, that's equal to 289. And this is all divided by 4. And I'm going to type in the square root of 289, and oh, that works out great. That's equal to plus or minus 17, all over 4. So here are my two solutions. I have -15 plus 17 over 4, and also -15 minus 17 over 4. And, I'll simplify those. This is 2 over 4, that's 1/2. Okay, then we have negative 32 over 4, that's equal to negative 8. And those are my two solutions to the original equation. X is equal to positive 1/2, and also x is equal to negative 8. So this probably means it wouldn't have been too hard to factor the original equation. You might want to try doing that to see how it compares, but this is directly using a formula to solve your equation. So one reason the quadratic formula is nice is if you have an equation that you can't guess how to factor, and I think that's going to happen for this example here. So we have x squared is equal to x plus 1. I mean, it seems simple enough. If we set it equal to 0 by subtracting x and 1, we could try to guess the factors, but I don't think we're going to be able to do that. I think it's going to be too complicated. So at this point, I'm just going to list down what a, b, and c are equal to. It's 1, negative 1, and also negative 1. And I'm going to go from there. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times 1. All right, there's a lot to simplify here, but our negative is a positive 1 plus or minus the square root of, that's a positive 4, and a negative 1 squared is also positive 1. That's the square root of 5, and this is all divided by 2. So here's the issue. You ended up with the square root of 5, but you can't simplify that any further. I mean, if you try, it would just give you some strange decimal. So actually, the square root of 5 is an exact answer. My two solutions are x is equal to 1 plus the square root of 5 over 2, and then x equals 1 minus the square root of 5 over 2. You can't simplify it any further. So those are the two numbers that make my original equation true. If you want a nice challenge, you could actually plug those in and make the left side equal the right side to give it a shot, but I'm pretty convinced that these two are the correct answers. And this is why it would have been hard to factor this equation. The numbers you'd have to guess are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2, which, I don't know, I don't think I would have come up with that. So if you can't guess the factors, then you can go through this formula to get your exact answers. And for the last example, example 4, we have a quadratic. There's no x term that appears in this. I think something's going to go wrong when we try to solve this one. I want to run this through the quadratic formula to see what happens. If I'm being really careful, technically this equation is x squared. There's a 0x term and a plus 4 is equal to 0. So you can more clearly see that a is 1, b is 0, and c is 4. I'm going to plug that in to, let's see, we have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times 1. Looks a little strange, but if I simplify this, I have x is equal to, well, negative 0, this is going to be 0. I do have plus or minus the square root of negative 16 all over 2. And if you type in the square root of negative 16 into your calculator, it's probably going to give you an error. And this means there's actually no solution, no real solution to this equation. If you have the square root and you're using this formula, and you have a negative number under the square root, I know there's going to be no solution to the equation. There's no real number that could possibly work, which is a possibility. You can have a quadratic that has absolutely no solutions to it whatsoever.